Hi everybody, welcome back to my channel. This video is going to cover fractions, basically trying to help you build an intuition about fraction as parts of a whole, and basically all of the things that surround that, with addition, subtraction, with fractions, everything in that realm. This is a video in my pre-algebra series, which comes after integers, so if you haven't checked out my integers video, go check that one out first. That will be kind of a precursor for this video. Okay, let's get started. First of all, let's talk about what a fraction is. Essentially, what a fraction does is it represents a part of a whole. Now, what do I mean by that? Let's imagine that we have a pizza, right? So this is my terrible drawing of a pizza, but let's say it's split into, 8 equal pieces like this. And we're trying to give some friends different slices of pizza, okay? So let's say we have 3 friends, okay? One that eats a little bit less than the other 2. Okay, one way to break this pizza up would be giving 2 friends, right, 3 slices of pizza. So friend purple, or friend number 1, gets these 3 slices. Friend 2 gets these 3 slices, right? Whoops. Gets these 3 slices. And then friend 3 gets these slices, right? So 2, 3. Okay, so what have we just done? Well, friend 1 now gets 3 out of 8 slices. Now, what do I mean by that? Well, we see that there was 8 equal slices in the beginning, so we've cut the one whole pizza into 8 pieces. That means each slice is what we call 1/8 of the total. Now we can think about this pretty simply. If we have all 8 pieces together, what does that mean? Well, that means we have 8/8 of the total, or just 1, right? 8 divided by 8, that's just 1. Now, let me quickly define what I'm doing with this kind of division symbol, right? A fraction, you basically put the total number of pieces on the bottom. Total, we call it the denominator. Okay? And then on the top, what's called the numerator, we put the parts. Basically, the number of parts included in our whatever fraction we're valuing, right? So we call that the numerator. Okay. So if I wanted to look at 3/8, for example, 3 would be the numerator. That's the number of slices that person 1 is getting, right? And 8 is the total number of pieces in the whole pizza. So basically, this tells us how many pieces. This tells us the size of the pieces, right? Because if, say, we split the pizza into 50 pieces, right? Same size pizza into 50 pieces instead of 8, or 50 slices, right? Then 3/50ths would be a lot less pizza, right? It would make the slices themselves would be smaller, and although we're getting the same number of slices as we did with 3/8, 3/50ths is a lot smaller. So comparing fractions, that's something that trips a lot of students up. So let's really talk about that, right? If we have, say, we're trying to compare the numbers 1/2 and 1/3. Which one of these is bigger? Well, immediately we see that 2 is smaller than 3, so we might think that 1/3 is bigger. But with fractions, that's not quite how it works. Let's think about visually what 1/2 means. 1/2 is saying, okay, so I have this pizza, okay, and I eat half of it, this much. Well, what is 1/3 saying? 1/3 is saying I have the same pizza, but instead of eating half of it, I'm eating just this much, right? 1/3. So which of these actually means more pizza? Well, it's pretty clear this is the bigger slice because we're breaking it into less pieces, right? So each person gets 1 slice, right? 1 slice in each case, but the 1/2 slice is larger than the 1/3 slice, okay? Now, this kind of visual demonstration should hopefully help you understand that 1/2 is bigger than 1/3. It's greater than. Its value is larger. When we're asking which fraction is larger, we're asking which person is getting more of the pizza or more of the pie or whatever you would like to use to visualize it. So let's do another example. This time, instead of having different denominators or different denominators like 1/2 and 1/3, let's talk about maybe 2/7 versus 3/7. Well, which one's bigger here? Well, now we have the same denominator, so the slices are the same size, right? We have a pizza that looks like this, okay? 1, 2, 3, 4, 5, 6. Oh, I broke that into too few pieces. There we go. So assuming those are all about the same size, which they're not exactly the same, but we can visualize it as if they were all the same size. These two slices, right, those two slices right there, is not the same size as those two slices plus a third one, these three slices right here. Okay, so the 2/3 or 2/7 is actually smaller than 3/7, because if the slices are the same size, well, then we can compare them directly. Who is getting more? Well, this one's getting 3 slices, whereas this one is only getting 2 slices, so 3/7 is bigger than 2/7. Okay, so this is kind of how we compare fractions between the two, especially when they don't have the same denominator. Now, let's see what we can do if they have vastly different denominators that we can't just think about in our mind which one's easier. Like 1/2 to 1/3 was pretty clear, right? Because obviously 1/3 is going to be smaller because it's split into more pieces. But let's say we're trying to compare 5/12 and let's see, 1/3. Which one is actually bigger? Okay, so immediately I can't really compare between 12 and 3 slices that well in my mind. But there's a way to compare these. The goal to compare two fractions is finding a like denominator. And the way that we do this is we find the greatest or least common multiple of the two denominators. And if you don't know what a least common multiple is, we described this in a previous video in my Foundations of Mathematics series. You should definitely go check that one out. But coming back to here, we need to find the least common multiple of the denominators. So what's the least common multiple of 12 and 3? Well, the way to do that is we prime factorize 12 and 3. 12 is 2 times 2 times 3. 3 prime factorized is just 3. So what that leaves us with is, well, these two are the same, so we multiply by 1, 3, and then we multiply by the other two things, times 2 times 2. Once again, if you don't really follow what I'm doing with LCM, go back and check out my factors and multiples video. So 3 times 2 times 2, so the least common multiple between 3 and 12 is just 12. So now what we have to do is we have to convert 5/12 and 1/3 into fractions with denominators of 12. Well, 5/12 is already a denominator of 12, so we don't have to convert that at all. 1/3 is not a denominator of 12, though. Well, how do we convert it? Well, 12 is just 3 times 4. So what we do is we multiply by a trick. We multiply by 4 divided by 4. Why are we allowed to do this? Well, 4 over 4 is just 1. So we're allowed to multiply anything by 1, and multiplying by 1 doesn't change the fraction's value. So if we multiply by 4 over 4, we're actually left with 4 over 12. 4 over 12. And now what we've done is we've written that 1/3 is equivalent, it's equal to 4 over 12. And now we can compare these directly, right? Which one is larger, 5/12 or 4/12? Well, each of the slices are the same size now, and who's getting more slices? Well, 5/12 is getting more than 4/12. So in order to compare 5/12 and 1/3, we had to convert them to the same size, the same number of slices, the same denominator, and then we can compare that 5/12 is in fact greater than 1/3. Okay, so this hopefully was a proper introduction to fractions for you. Let me know in the comments if you have any questions. And once again, if you're confused how I found the least common multiple to figure out the common denominator that we need, we want you to go back and try the Foundations of Mathematics video on factors and multiples. Like and subscribe, and I'll see you in the next video.